Hello, so we're back, and this time we have a proper nice laptop to repair. HP i7, Iris graphics, a proper heavy machine, 17-inch screen. Now, what's the story with this one? We have no idea what's the story with this one. We don't know who is the customer. We don't know what problem is with the laptop. I didn't test the laptop, so I have no idea. The thing is, if a customer it doesn't attach the service request number as instructed, I don't know what's the story with the laptop. I don't know from where it's coming. I don't know what problem it is. So we have to find out what problem has this laptop and also fix it. We have a blue pin HP charger. I mean, on some point, probably someone will cry about this laptop, but till that moment, I have no idea. Now we have like 19 volts on the power supply. Plug in the charger. And we have no light there. You can see. So basically it's no light. Pressing the power button, nothing happened. So basically the laptop is dead. Okay, good. Now let's open the laptop. It actually doesn't have screws. Yeah, no screws. And the laptop is open. That's a nice motherboard. Based on the color, I'm assuming it's some liquid damage job. I mean, I can see those capacitors, they have a different color. Huh? You see? So can be a liquid damage repair. Now, because we have a normal USB, we have a normal charging port. Now, because we don't have USB-C here, we have a normal port. This can be a easy pizza, yeah? So let's check first. What we are checking is if we have any voltage at the input. Very simple, yeah? Just to understand if the charging port is good or not. And we have 19, 20 volts, right? Yeah. The next step, main power rail, coil, MOSFETs, capacitor. And here you have 0, and here you have 0. So the main power rail is not present. So yeah, that's a reason why this laptop is not working. Now the next logical step. 1 second, what do we have here? What do we have here? Check that. Coil for MOSFETs, yeah? So that's a power supply which is probably creating the main power rail. But on this power supply, we should have input voltage, right? And the input voltage, check on the screen, 19.9. So the voltage is reaching this power supply, and the output of this power supply, which is here, is 0. So this power supply is not working. I'm assuming this is the driver of the power supply. Let's go under the microscope, or not. I mean, main power rail is 0. Let's check for short. Yeah, at least we know if the main power rail is shorted or not. Main power rail 0 ohms. Check on the screen. It's not even point disconnecting the battery. The main power rail is shorted. The battery is disconnected anyway. Has a protection system in case something is shorted. The cells, it will get disconnected, and the battery will get reactivated in the moment you apply voltage. Yeah. So no even point disconnecting the battery. But start looking like a easy pizza. Huh? Let's see. Let's see. So we need a ground, a solid ground. Yeah, this can be a solid ground. Yeah. Let's see if it's ground. It is ground. We have like 4 amps. A little bit too much. Yeah, 1.5 amps. Let me grab the thermal camera. The thermal camera is here. Let me try to zoom out. Yeah, like that. So we are coming with the power supply here, like straight on the capacitor. Here we have, you check the voltage, yeah? Because the current has a limit 0.02 and 0.2 and here 0.2. What? Basically this short is so short, I can't even push current. Let's raise the current. Here we have 0.5 and here we have 0.4. So I'm assuming the plus is here, but 0.4. The resistance is incredibly low. So this is a proper shorted capacitor, I'm assuming. No, it's not a MOSFET, it must be a capacitor. Something is hot there, you can see. Something. And I can't see something else. And I can't raise the current more, right? Yeah, 4.6 amps. That's all what I can do. Now, clearly there is something dodgy. Let's have a look. Can be that MOSFET? Can be a MOSFET? Okay, let's check the coils. Yeah. This coil has 0 ohms. That's bad. That's proper bad. So I have 0 ohms here. That means this power supply is connected to the main power rail. No pizza. No pizza. I can't see any pizza. Wait, someone work here. Right? I mean, check there. Someone work here. Yeah. So the chip is shorted. Something is missing from here. And we don't know what chip it is. We don't know what voltage it is. Okay, so look what is the deal, yeah? So the deal is, if we are taking out the chip and the coil resistance is going up, then we are moving forward. Otherwise, it's kind of pointless. Let me use some Kapton tape. Perfect. Now let's get that chip out. So who sent that laptop? Work on it. Yeah, the chip is out. I have no idea what chip it is. Huh? Do you see anything on the chip? It's like something is saying there. Okay, let's check the coil. So the coil has 0 ohms. Yeah, end of story. Yeah, end of story. End of story. When you have a 0 ohms coil, the main power rail probably is not shorted. And we can check that. Main power rail not short. Yeah. So what power supply is that one? We can find out. The current just dropped to 2.2 amps, and what is getting hot. Okay, the array is hot. Okay, I got it. Yeah, the array is hot. Good. So one more time. What is getting hot, I'm assuming is the chipset. You know, I can nearly bet is the chipset. But let's take out the heatsink. Okay, the heatsink is out. Let's see one more time. Check there. Chipset in one corner. Yeah, it feels bad. I know. Yeah. Chipset is shorted. What can I say? Anyway, if the customer with this laptop is watching this video, please email me because you forget to put the service request number. And on the same time, I'm sorry, but I can't fix it. Basically, this laptop needs another CPU. We can replace the CPU. That will not be a problem. I mean, can be a problem. We have to We need another BIOS file. We need another CPU. The problem is the CPU. Yeah, we cannot get a good one. The Intel is not selling CPUs, so whatever CPU we are finding to buy are actually recovered from faulty boards. And on a faulty board, most likely the CPU is faulty. So no, it's not worth not even going to risk and buy a CPU. Without that, without the short, probably the laptop it will start charging. And well, let's see. No, actually, it's not working. I can't believe. So we removed that. Oh, whoa, 1 second. It's 19. We need 19 volts. 1 second. Sorry. 19. Good. No, we don't have the charging light. Huh? So here are more faults than the CPU. It's more than that. So the input voltage is the same. The main power rail is... The main power rail is 16.7. Huh? So why we don't have the charging light? Let me press the power button. The laptop should come on. Nah, it's not coming on. No. This laptop has more issues. So one of the issue is this is not charging. Yeah. So because it's not coming on also, that means the EC chip is not reading the power button. That means the EC chip is not speaking with this chip to start the charging. Yeah, because the EC chip is speaking with the battery. And the EC chip is speaking with the power management chip also. So this laptop still has an issue with the EC chip. I'm assuming it's the EC chip. Because let's say, okay, this circuit is not working and it's not charging the battery, then the laptop should come on. We have like 16 volts on the main power rail, but doesn't look like any sign the laptop it will come on. Yeah, I'm really sorry. But I can't fix this one. So here you have multiple faults, possible because of the liquid damage. I can see based on the color of the capacitors. Yeah, it is what it is. Someone asked on the Sunday live stream, sorry, what about the right of repair? In the moment they will be forced to share, not only documentation like schematics and board views, but also spare components like the CPU. Then the world, it will be a different place, a better place, obviously. Okay, I'm gonna stop here. I will say thank you for watching. Like, subscribe if you like the video. And if you are the customer, just please email me. Bye.